Once again, welcome back to my YouTube channel. In today's video, we'll be dealing on calculations on Jamb questions. There are some questions you likely see in your Jamb, and I'm going to review those questions to you. Specifically, just these three. Maybe in my other videos, I'm going to review others to you based on calculations on Jamb and the easiest way or the method in which those questions can be tackled and calculated. Now, look at this closely. What mass of water is produced when 8.0 gram of hydrogen reacts with excess oxygen? Option A, we have 8.0 gram. Option B, we have 36.0 gram. Option C, we have 72.0 gram. Now, if you have a question like this, the first thing that should come to your mind is write a balanced equation of water. So I'll have hydrogen reacting with oxygen to give us H2O. But if you have a question, if you have something like this is going to give you hydrogen peroxide, and this is not what we are looking for. We are looking for water. So for me to make sure this equation is balanced, I'm going to put a water here, but with this, it's not still balanced. I'll place a 2 here, place a 2 here for me to get a balanced chemical equation of water. That's the first step. Then the second thing is that we have 2 mole of water here, 2 mole of hydrogen, 1 mole of oxygen, and 2 mole of water. Then what is the atomic atomic mass present here? The atomic, which is the round that is here, the one that is here, and the one that is here. So what I'm going to do is hydrogen is 1. 1 times 2 will give us 2. 2 times 2 will give us 4. I repeat, hydrogen, the atomic mass of hydrogen is 1. 1 times this 2, 2. 2 times this 2 here will give us 4. So I will have 4 here. Oxygen is 16. 16 times 2 will give us 32. Then here we have oxygen here is 16. Hydrogen here is 2. Then everything here times 2. So what I will do, 2 times 16 will give us 18. 18 times 2 will give us 36. So here is 36. 4 ratio 32 ratio 36. So after getting to this point, then we now come back to this. We have 8 gram of hydrogen reacting with excess oxygen. 8 gram of hydrogen. So let's have 8 gram here. If you have 8 gram here, then here that means I doubled for giving me 8. If I doubled for giving me 8, that means I'm going to double this as well. If I double this, I'm going to have 64 gram. So I can say 8 gram reacting with 64 gram to give me how many water? So I'm going to double this 36 as well to give me 72 gram. So 8 gram of hydrogen reacting with 64 gram of oxygen to give me 72 gram of water. So our answer here will be 72. So that is the easiest. This is just a shortcut for you to get this. I believe that there are other methods in which you can use, whereby you can just say 4 is equals to 36, then 8 gram is equals to S. So it's just for you to cross multiply. Then you have 8 gram times 36 divided by 4. At the end, you are going to have 72 gram. So you can either go with this method or you go with this method. But I believe that this method is simpler compared to this. So this is how you can tackle any question you see on your Jamb relating to this. So the number 2 question says, calculate the number of mole of hydrogen ion. Remember, whenever we are talking about hydrogen ion, it means an acid. Remember, we always say an acid is a substance which, when dissolved in water, produces hydrogen ion, hydronium ion, ozonium ion, hydrozonium ion as the only positive ion. So whenever you get a concept like this, please take note. We are talking about a guy called acid. So present in 1 gm cube of 0.5 gram solution of H2SO4. The first thing you have to do, write a balanced equation. Any questions you see relating in this format, the first thing you are expected to do, write a balanced equation. So I will have H2SO4. On dissociation, we are going to have 2H plus SO4 2 minus. This is taking us to another concept called basicity of an acid. Please take note, an acid can be monobasic, can be dibasic, can be tribasic, and all that. For example, if an acid ionizes and you have one hydrogen ion, it is said to be monobasic. If it ionizes or dissociates and it produces 2 hydrogen ion, it's said to be dibasic. 3 hydrogen ion is said to be what? Tribasic. If I have something like CH3COOH, on ionization, this is going to give me CH3COO negative plus hydrogen ion. So we have just one hydrogen ion here, so we call this monobasic. If you have it like this, you call this dibasic. And if you have something like phosphate, if you have 3 there, it is called what? Tribasic. Monobasic, dibasic. Y for phosphate is for what? Tribasic. That is what we mean by basicity of an acid. And if you have gone through some past questions, you are going to see likely questions on those areas. So if you look at this, we have one here, 1 mole of acid, it produces 2 mole. So one of them was able to produce 2. And that is to say, if you are looking for 0.5 mole, I repeat, if you are looking for 0.5 mole, then how many of them will be formed? That is 0.5, 1 mole is equal to 2, then 0.5 mole is equal to what? Then what I'm going to do is this, just for me to cross multiply. I'll have 1 times S is equal to 0.5 times 2. Then this can be written as S is equal to 0.5 is the same thing as half times 2. That can also be written as 1 times 2, that's 2 divided by 2. Then S is equal to 1 mole. So 1 is equal to 2, then 0.5 will be equal to 1. But as a chemist, I don't want to do all this long work. I can say if 1 is equal to, I always want shortcut methods, very short method. I can say if 1 is equal to 2, then 0.5 is half of 1, right? If 0.5 is half of 1, then what is the half of 2? Half of 2 is 1. So that's exactly the calculation we did to give us this. So the answer to this very question is option A. So the number 3 question says, in the reaction above, the standard rate of formation of CO and CO2 are this and that respectively. The heat change of the reaction is option A, option B, option C. Now the first thing you have to take note of is, write the balance equation of this. The equation is already balanced, yes. 2 carbon, 2 oxygen, 4 oxygen, yes, so it's already balanced. Let me bring the equation here. Please take note. Jamb and Waec will not like to kill you. Don't get it twisted. They will always give you a balanced equation. If you have something like in the reaction above, the equation above is always balanced. So you don't really need to confirm if the equation is balanced or not. Those people, they are experts, so they will always give you a balanced equation. But me, I don't trust anybody. Even you, I don't trust you. So I've already confirmed the equation is balanced or not. So I'll have 2CO, here is gaseous, plus O2, here is also a gas, to give us 2CO2, and here is as well a gas. So for you to calculate the heat change, delta H is equals to HP minus HR. That is the heat formation, the heat of the product minus the heat of the reactant. Please take note, this is the product, while this is your reactant. If you have done a titration before, that is a volumetric analysis. For those of you who have already done Waec or have written your Waec, or if you are, by chance you might have gone, if you have watched my video now, I believe by chance you have done a titration practical on an acid and a base. So the acid and the base you have at the beginning of that your reaction, they are your reactants. And at the end of the reaction, remember, it's a neutralization reaction whereby a salt and water is formed. The salt and the water you are going to form at the latter end of your reaction, it is called the what? The product. So this is your reactant, while this is the what? Is the product. So they said the heat formation of the product, that is CO2. CO is reactant, while CO2 is product. So the CO2 is minus, yes, 396 kilojoule per mole. Then the heat of the reactant is minus 297 kilojoule per mole. Now, most of you will work with this, but this is as well wrong. What you are expected to do is that we have 2 mole here and we have 2 mole. So here will be multiplied by 2. This place will also be multiplied by what? By 2. Assuming here is 3, here will be multiplied by 3. That's the answer for a balanced chemical equation. Because if the equation is not balanced, the answer that you might get might be here, but it is as well very, very wrong. So please, it's not about you getting an answer, it is about you getting the correct answer. So let's try this. If you have minus 398 times, 396 times 2, we have minus 792 kilojoule per mole, minus, then let's try this. 297 times 2, we have minus 594 kilojoule per mole. So if you have a question like this, then what we have to do is minus 972 kilojoule per mole, minus in mathematics is going to give us plus. So we have plus 594 kilojoule per mole. So if you punch your calculator, minus 972 plus 594 is equals to minus 792 kilojoule per mole. Yes. So if you punch your calculator, you are going to have minus 198 kilojoule per mole. So let's trace it here. The correct answer is option B. So option B is the correct answer to this very equation. We are going to have minus 198 kilojoule per mole. Please take note. The formula is delta H is equals to the heat of the product minus the heat of the reactant. And please, you are also expected to note the number of moles present in the particular equation, because if the equation is unbalanced, there is no way you can get a correct answer. I believe you have been able to understand one or two methods in which you can solve equation number 1, number 2, and number 3. Thank you for watching. God bless you. Please don't forget, share with your friends, subscribe, like, comment, and stay tuned.